So the next shortcut we are allowed to use to prove two triangles are similar to each other is side, 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 which you might be thinking, Ms. Briscoe, we had side, side, side as one of our shortcuts for triangle congruence. Well, it's not that we're trying to prove three pairs of sides are congruent to each other. We're trying to prove that three pairs of sides are proportional to each other. So the ratios have to be equal. So if the three sides of one triangle are proportional to the three corresponding sides of another triangle, then that's enough to say that the triangles are similar. We don't have to know anything about the angles. So if AB, the ratio of AB over XY, oh, actually I should probably use red. AB to XY is equal to the ratio of BC over YZ, which is equal to the ratio of AC over XZ. Then that's enough info to say, those triangles ABC should be similar to triangle XYZ. So I'm matching up a side from the left triangle and putting it over the corresponding side from the right triangle, left over right, left over right. So as long as you stay consistent, it doesn't matter which one is in the numerator and which one's in the denominator, you just have to be consistent with all three ratios. So we're checking to see if those three pairs of sides are proportional, not congruent, proportional. And then that's enough to say that the triangles are not congruent, similar. So let's check and see if these triangles are similar. So I have three sides, triangle ABC, and three sides on triangle DEF, and I need to match them up, but I don't have any angles to help me determine what the corresponding parts are. So I'm going to start with the smallest side on triangle ABC, which is 10. The smallest side on triangle ABC. I'm going to match that up with the smallest side on triangle DEF, which is 12. So small over small. Then I'm going to check the middle side, which is 12, over the middle side, which is 14.4. And then I'm going to check the longest side, 15, over the longest side, 18. I'm checking those three ratios. So I can just type those in my calculator. 10 over 12 gives me 0.833. 12 over 14.4 also gives me 0.833. 15 over 18 gives me 0.833. So if I'm just checking to see if those are proportional, I don't need to worry about if it's a fraction or decimal. I'm just trying to see if they're equal. So yes, these ratios are all equal. So yes, all of these sides are proportional. So I can say that those two triangles are similar. I can say triangle ABC is going to be similar to triangle DEF by side, side, side. If I was asking you what's the similarity ratio, this decimal is not okay for the similarity ratio, but the similarity ratio would just be found by simplifying this. So it would be 5 over 6. And then on this next one, I'm going to match up the short side, which is 8, with the short side, which is 10. And then the long side, which is 12, over, it doesn't matter which one because it's isosceles. So I'm going to do it twice just to prove a point that I gotta check all three pairs of sides, but this one's special because it's isosceles. 8 over 10 reduces to 4 over 5. And 12 over 15 also reduces to 4 over 5. And so that's enough to say that yes, triangle ABC is similar to triangle MNP by side, side, side.